See a mirror image, but just bear with me because there's quite a lot of tabs that I want to share with you at the same time, and I don't want to change tabs every single time. So here we go. I might not always be able to see the chat, but you can just let me know if I'm missing anything in the chat, and I'll get to it as soon as I can. Okay. So it'll be nice if it's nice and interactive. Because I think a workshop should be quite interactive. But at the beginning, you'll find that it's going to be fairly highly theoretical, just to get a nice foundation. Okay. All right. So experimentation and tools for effective data collection. And I'm from computer science. I'm Dane Brown, for those of you that don't know me. And of course, I'm from Rose University. So just the introduction is going to look at a little bit research first. And then from there, we're going to work our way into data collection, because you don't just collect data, right? You first establish what you're trying to look for. Okay, so let's see from the chat. What is data? Oh, sorry. Before what is data? What is research? So before I give that answer, I'm curious to know what you think research is in the chat. And I think since we are only about 30 participants, maybe we could do some voice answers as well. So I think that you can switch on your microphone and chat via voice if you want to as well, if chatting via the chat box is too much effort. So anyone want to take a stab at what research is in an academic setting? No? Waiting for my answer. Okay. So since no one is going for it, I'll go for it instead. Oh, okay, you raised your hand. Come on, Fisa, go for it.
Yeah, thanks. Good afternoon. I think for me, it's the standard and it's a systematic inquiry. So where you're trying to
Yes.
find out something, but then you're following a process that's sort of acceptable and is laid down in a certain way.
Yeah, exactly. And that's very close to the definition that I was about to give. I see in the chat as well, there's a cyclical process. Yes, it's often iterative. That makes a lot of sense. Building knowledge, adding to the body of knowledge, gathering and collecting information. Okay, cool. And I see geosciences has joined us as well. Cool. Oh, that's a very good answer. So it's something that also involves questioning what and why, especially the why part. The what part we often looked at school quite a lot, right? So the what part was something that we were almost I'm not going to say brainwashed, that's a very strong word, but it was pushed hard into us that this is like this is like that, this is like that, in a very horizontal way. And it's only really at university that we started to see that much of the knowledge that we have is hierarchical. Not all of it, but much of it is. And it feeds into the next step, and there's a lot involved in the process. It's also more than a set of skills. The how is a procedure that you can't just learn, you can't just memorize, because just knowing the procedure is not enough. You can know the procedure for baking a cake. That doesn't mean that you'll be the expert overnight. Some people are naturals though, so I wish I was one. But yeah, so examination of observed information to find answers, and there's all kinds of other definitions as well. So what is the derivative of research? So if we broke up the word into re and search, what are we basically saying? So we know re means over again, do it again. And search, in this case, is something very deep, very detailed. So when we closely examine something in a very deep, detailed way, we often probe, we try, we test, we try, all kinds of different ways of doing this, right? But we often do it again. So I liked that answer earlier when someone said cyclical process. Sometimes the process is measure twice, cut once, though. So not every single thing I say today in this presentation is going to apply to everyone. So there's a reason why I asked what your discipline is, what your field is. Robert says that it's a wonder that we seek to find answers to. Yeah, that's also very good. So it's about curiosity, right? So we seek to find answers based on that curiosity. Often in the more sciencey based stuff and the academic context, we say meticulous, systematic study, and that was one of the first definitions that was given. Okay, so before we can do data collection, we first have to be guided, right? We need to know what we're trying to look for. So before we can do that, I'm going to mention the word that some people like, but I find that many people dread, and that is literature review. First, we need to read a lot, right? We need to read a lot before we can do things. We don't want to just do things in a haphazard way and uninformed way. We want to first be informed on what we're doing. And we often start off quite broad in this process. We start off very broad before we find an area. Sometimes that area has a nice gap, or sometimes it's just questions about that area, small questions that still need to be answered. That if we do answer those questions, we can add to the body of knowledge. And that adding to the body of knowledge is not always a positive thing. It's not always a practical thing. It's nice when it is, but it's not always, right? So basically, there's a parent discipline that you have, and you start wide. You have background readings in the second level, and you want to go deeper into what you're actually trying to do. And by going deeper, you actually start to understand your entire parent discipline slightly better. Now, when you get to PhD level, that becomes a lot harder though, and a lot more specific. And sometimes it doesn't really make you understand the parent discipline a lot better because it's often a very niche, tiny, small little dot that you're looking at. But in general, research often helps you to understand the parent discipline better. Okay, and not every discipline likes very up-to-date things. Now, a lot of these slides were adapted based on computer science principles and academic research that I teach in our department. So not everything's gonna apply to you, like I said, but we often look at very up-to-date things because computer science in general is quite fast-moving as a discipline. Although there's a lot of theory that hasn't changed for many years now, for decades, in fact. Um, and computer science existed before computers existed, which is also fairly funny and interesting. So it often stemmed from applied maths. But that's something we can talk about in another workshop. So just a little bit more on the theory stuff before we get to more closely to the data collection stuff, and then we can start looking at some applied stuff. So often when you read something, right, you start off at a very recent thing. Sometimes it's a survey that's just maybe a very high impact survey that's from a reputable source, and you try to work your way backwards, but not necessarily 2025 and then the next um, the next article that's older and then older and older and older. Sometimes you jump all the way down to 2015 to find that seminal study, the study that really started it all, and the study that might help you to find the gap a bit better. And I mean, in finding that, it can help you to know what sort of data you need to collect in your own study, because once you have that thing, that niche that you find that you're trying to solve, you have a problem statement, you have objectives, you have something that can help you to guide your research a lot more so that you can collect data in a way that's guided. Of course, just generally speaking, you don't want to use bad references or bad sources. Predatory lists such as Beale's list is available. I'm happy for everyone to get the slides after the presentation. So I did make some hyperlinked things in case you're interested. Now remember, the reading is difficult, right? Because even if you're very good at reading, there's like infinite sources on the internet. And I know some areas are understudied, but it's very hard to read a lot because of time. And we have many other things that we need to do as well. Or if you're doing a master's, you have a finite amount of time to finish your studies, right? Or if you have a bursary, etc. If you have any sort of funding obligation, really, you often tie to a schedule. So you have an initial appraisal in how you read things. You're often looking at the author at some point, and you'll ask me if you're a student, but how do you do that? You don't really know people yet, right? Your supervisor will often help you to guide you in that process. They'll know author surnames quite well normally. And there are a few other things like date, editor, publisher, are they reputable, etc. But it's the title and abstract that really makes you understand what you're looking for a lot more and whether it's worth fully reading the article or not. So when you have specific questions in mind when you read the actual article and you feel like it's a good enough article after you do the initial appraisal, the why is often the biggest question that you ask yourself. Why is this research important? What's the point, right, in doing this research? And then what were they trying to discover and how was it implemented? And this is very useful for your data experimentation and design. So principles of effective study design. You need reliable, valid, and reproducible research. And in order to do that, since we in 2025 now, right? We're in the 21st century. We have all these new amazing tools that it's available to us. But don't just take for granted that all these tools are reliable, valid, and reproducible. So hopefully after I take you through some of these tools, that'll become a bit clearer as well. But especially for those of you that rely on AI as a crutch, be very careful about that. Lots of the information looks very credible, looks amazing, looks great, generates the information quickly for you. That doesn't mean the information is accurate or valid. Okay, some key aspects. So, of course, you could do data collection and sampling strategies. For some reason, Zoom is popping up here with messages. I'm not really sure why. Okay, I've just closed it. So once you read the right things in the literature, and of course you have your supervisor to help sanity check this with you, you'll be a lot more guided and you'll know what sort of data to look for and what sort of sampling strategies other authors use so that you don't just go out there and start collecting data in some random way. You'll have an experimental design, so you'll know almost before the time already what sort of structure you're going to have in your experiments. You don't know what your results are going to be yet, but you know more or less what your design is going to be. So you need to plan things. If you don't plan things, you're planning to fail. Controlling confounding variables, especially the sciences, that's something that's very important. You want to know some causal effects of maybe two variables. You can't have a third variable that's unaccounted for, that's unmeasurable. You need to be able to account for each variable. And this sort of thoughtful, the nice thing about this thoughtful design is that it minimizes bias and it improves precision. So others will be able to reproduce your research and you're not biasing your research in some sort of way, whether that bias is to a particular group of people, whether it's to a particular outcome that's positive. There are various kinds of biases, right? So when do we do this data collection? Like when does this actually happen? Now, this is coming to the end of the introduction now, but basically what I want to tell you, especially if you're a student, what are you going to do today? Are you going to work hard or are you going to play hard? Are you going to do both of those things? How do you even get that right? So how do you become a very good researcher, in other words? How do you schedule a time? Well, my answer to that is work first, play later, because how do you know whether there's enough time to finish your work if you don't work first? So first finish what you need to do and then do all the other fun stuff later on. But of course, life isn't just about work. So let's just do a quick Q&A break before we get to the actual data collection theory and to the practical demonstration of the tools. So are there any questions at this point since I've been blabbing for quite a while now? I don't see any hands and I don't see anything in the chat. So I'm going to continue now. And just before I continue, something that I think that's important to keep or to note for those of you that are perfectionists especially, done is better than perfect. What does that mean? It's something that Sheryl Sandberg said, which was the CEO of Facebook. What does done better than perfect mean? Please just got to the slide. Not really sure what that means in the chat. But done is better than perfect. Does anyone want to take a stab at that? So you have all this research practices that you need to follow, right? I've told you you can't just jump into the data collection immediately. It's not something you can just know, right? You first need to be informed. You first have to read up on things before you can just start this data collection process. But what is done is better than perfect. No one want to take a stab. Then I'll take the stab instead. So we're going to look at it again later. But what it's saying is do things as well. Don't just think about things and procrastinate. Okay. So doing things in a way that actually completes the task is useful. Show the slide principles of effective study design for a few seconds. Okay. So before we continue, I'll do that. So I'm assuming it's this slide. Yeah. Okay. Is there anything in particular that you wanted to see over here? So I will provide the slides afterwards. So everyone will get the slides. You can look at the slides again in your own time. Reliability, validity, and reproducible research will be looked at again as well. So don't worry too much if you miss everything on this slide. But your key aspects here are really, when you're doing data collection, it needs to be informed. So you need to know what sort of strategies you're going to use during the collection. How are you going to collect the samples, for example? Okay. All right. Now, just a little bit of a teaser here because I'm from a data science background. Confounding variables, that's what you want to know. So confounding variables are something that's mostly in science, so in the fields of science, but it can apply to many other fields too, including economics, etc. But if you have multiple variables in a data set that you've collected, right? You don't want there to be many variables that you don't understand. You want to at least understand certain variables that you can keep static. And there are there are various ways of doing that. Something called regression comes to mind as the first way to be able to control variables. So if you have two variables and you make a statement that, you know what, um, these two variables over here, they are strongly correlated, and this variable causes this to happen and strongly affects this variable. But then you have another variable or another two variables that you've not controlled in this experiment. So a variable that is unmeasurable, you don't understand what's going on in that variable. That normally constitutes a bad experiment. And that's basically what we're trying to say here. When you're designing experiments, you want to be able to control your confounding variables. And there's various tools to do that. Regression is often one of the big tools that are used to do that when you're dealing with quantitative data. But more on that later. I hope that kind of at least explains it. So a data science teaser before we get to part two, which is really the crux of this workshop, where we get a bit more practical. Now, I'm from a data science background. I do a lot of machine learning. You're welcome. And these AI tools that you're using, I sometimes use them. I try to not rely on them, but I often create or optimize different algorithms that are used to create these different AI tools in the first place. So if you think about it this way, it's like opening up the hood of a cool car, like this AI car, right? If you open the bonnet and you check, oh, these are the cool parts that are under it, and this is the different kinds of tweaks that the engineer did. That's the sort of stuff that I do. And the reason I'm bringing this up is because I just want to show you a way that might feel like it's common with many of you, not all of you, but many of you. The way that data science often approaches things is we often look at the design first, where we identify the problem. Now, I mentioned earlier that you need to read up on the literature before you can even do this. Because to identify the problem, you need to be informed. And then based on that, you can also find out what sort of data sources you need. So is it going to be a water sensor? Are you going to look at different dam levels? What are you trying to measure over here, right? And what do you need to be able to monitor? Or is it going to be on people? Are you going to go to a village? Are you going to interview people? So what type of data sources are we looking at here? That's very important. Next is, now that you know what sort of problem you're trying to solve and what sort of instruments and data sources you can use, we can do the actual data collection. Once you've collected the data, hopefully in a very, very structured way, using tools that are appropriate for your kind of data that you're trying to collect, you need to prepare that data or curate that data. And in data science, often we read in the data. Sometimes we integrate the data with other kinds of data that's compatible with it, because in data science, we often feel more is better until we get to the point where we need to model the data. Now, before we can model the data in the data experimentation part, we first have to transform the data, clean the data, filter the data, aggregate the data in a way that is meaningful, such that the model does not have to deal with too many variables that are confounding. So many of the models that we have in computer science and in data science is very good at working out what variables correlate to other variables, right? And what variables influence other variables. And it's very good at keeping certain variables static as well, so that we can focus on very specific variables that are of interest to us in an experiment. But sometimes you need to transform the data in some ways to make it better, to be able to do that process. Now, during data experimentation, sometimes we don't really know what we're looking at because the data is too complex. So we often have visualization methods to deal with that. Now, there are various tools that can deal with this that I'll look at just now. Sorry, once we get to the practical side. So now, once we are happy with what we're looking at, once we can analyze the data and we feel like, okay, we're happy, we can start modeling the data now. We know our variables. We know what our independent variables are. We model our data in a structured way. And finally, we can evaluate. Now, evaluation again largely hinges upon you reading your literature and understanding what constitutes success. How do we know whether we've successfully solved our problem? And whether it's the problem or if it's just a general exploratory research idea, you need to find a way to measure something. Once you've done that, you can communicate your results, and depending on your audience, that'll be done in various different ways. If it's a business-based project, it'll be done in a certain way, often very graphical, using data analytics. If it's an academic project, it would constitute a thesis, maybe going to conferences, maybe publishing papers, doing that sort of stuff. What projects were successful and unsuccessful? So Google Flu Trends is something that does data analytics. And data analytics is part of data science. It uses stuff called descriptive statistics, inferential statistics, hypothesis testing, etc. And apparently it detected outbreaks weeks ahead before certain things happen for several countries. But by now you should know that this is often the case for very specific countries. And this is the bias that I was talking about earlier. Sometimes we use these models, and sometimes countries like the United States are favored, right? And it's only really when Google flu trends in 2015 really failed and made many false predictions about certain countries that they realized, you know what? We need to collect the data in a much broader way. We can't just look at the global north. We need to look at other countries too. So good new models started popping up, and they started to estimate cities that are at risk for Ebola in a very good way. So since that screw up, I would say in 2015, things have come along quite nicely. So that's an example of data biasing, where you don't have enough data in every single country, and then you make a general statement that, you know what, outbreaks are going to happen all across the world. You don't always want to do that. You don't want to just make a sweeping statement without being able to back it up with the data. So you need to model the country that you're actually predicting for. So what else can data scientists do? Something that I often do is machine learning. Um, Something you can't just use web scraping or just general data collection for. You need to use very complex algorithms because when you collect data from Google Scholar, for example, maybe there are 80,000 papers that are related to something that you're searching for. So let's say the paper is called the cost structure of sense making, and you want to find what the seminal references are, what the linked papers are, etc. It's not a very easy task to do, but there are programs that use machine learning and AI that come up with different ways of mapping this. And you'll see some of you might have heard of connected papers. If you have, maybe just mention in the chat that you have. I'll be curious to know if any of you have heard of it before. Connected papers shows you what's the most cited source, what's the least cited source, what's the most relevant source, what's the closest to the area, etc. Someone says litmap, so that's another cool tool that you can use for that sort of process. So there are all kinds of cool tools like that that exist, and most of it make use of different kinds of AI platforms that are based on machine learning. But in order to do machine learning, you need something called data, right? And I think data is a big part of what we're talking about today. That program that you saw over there now was a very old program in 2011 that was called Apollo. I won't call it Apollo because it only has one L. It went through that same data science process that I mentioned earlier, but it didn't do the data integration step, because you don't have to do every single step in the process if you already have the data. Okay, let's finally head to part two, which is data collection. So the crux of this actual presentation, right? So before we look at data collection, what is data? Data is observable and measurable facts. So it's facts about phenomenon that we are interested in normally. So we studying that phenomenon. Data is actually a plural word, which is quite interesting. So data are, not data is. Datum is the singular form of the word data. Quite interesting. And I thought I'd just include some example variables over here: age, weight, height, BMI, etc. These are all variables that most of us know about, right? Even though it's outside our field, maybe we'll still know what those variables mean. There are various places you can collect data in. Some stuff, I'm involved in projects involving plant disease, so it can be natural-based stuff. It can involve transport, optimizing transport or self-driving cars, financial economics, doing A/B testing, testing which product is better in a business, weather, cultural. There are several kinds of data that you can look at, right? But back to this slide, which we looked at earlier and returned back to. The methods and tools that you use, first and foremost, need to be reliable, valid, and reproducible. So you need to have consistent outputs from your methods and your scripts. It's pointless to use this amazing tool that speeds things up dramatically, but it keeps spitting out things that are unreliable and you keep having to correct it. So I know sometimes there are incorrect outputs from different tools that we use, and we live with it. Sometimes it's a minority. And I do feel like you can live with that kind of thing, but you don't really want to use a tool that is wrong most of the time. You also need to be able to trust that once you've looked at the result and you've maybe validated the result, right, that it's accurate in what it's doing. You also need to be able to, so once you've gone through the first two very important sanity checks, right, you need to also check whether it's reproducible. So can you reproduce those findings? And that's often just based on the way you read literature. You'll see that literature, good literature, is often reproducible, and you would follow a very similar process. What happens if it's not reliable, valid, and reproducible? Keep in mind that the data that you collect, if it's bad data, your output is going to be bad too. So measure twice, cut once is quite important. Sometimes it's not possible to collect data perfectly. I understand that different disciplines and areas don't allow you to do that. But garbage in, garbage out basically just means that you need to be meticulous. You need to try and collect high quality data. So how how can data be low quality though? Or how can this process be flawed? Well, even if you plan everything correctly, sometimes when you collect data, you need to collect data in a way that could be tedious, right? So You might have to repeat the same task over and over as a human being, and we get tired. Why do you think I like computers so much? Anyways, so humans get tired, right? So if it's a questionnaire or an interview that involves manual work, so maybe it's a questionnaire that involves you traveling on foot to each house, that can be quite tedious, and sometimes people get impatient, and that's how errors occur. So you just have to keep in mind that you need to try to be as meticulous as possible, especially when you're not doing work that involves using a computer that doesn't get tired and that can do things in a reliable way if it's set up that way. Okay, so poor data can lead to misleading facts regardless of the analytical sophistication. So that basically means that it doesn't matter how well you read, it doesn't matter how well you set up the data collection steps and the experiments and the design of the project. So it doesn't matter how sophisticated this analytical process is, if you collect poor data, you can lead to misleading findings. Okay, so what sort of research methods and data types do we get? So many of you are familiar with this already, but we get different kinds of data, right? And research methods normally, there are normally three main research methods that we look at, and that's quantitative, qualitative, and mixed methods, which is a bit of both. So what's quantitative? Quantitative is often when you're dealing with a lot of numbers. So like I used the dam levels example earlier, if you have a sensor maybe put into the dam, maybe you have a temperature sensor. Um, but it can also be having a questionnaire that has Likert scales or other sort of things that have different scales with numbers in it that collects data in a factual way in numerical and stores it as numerical data, right? So once you have numerical data, it's almost always going to be quantitative. But then you also get qualitative. And what's qualitative here? Qualitative can often be opinion based. So you could collect data from Twitter or all kinds of other social media feeds, and it could be opinions on stuff, and it could involve sentiment. So understanding what people are trying to say and what their feelings or emotions are based on that. And that often involves using various kinds of tools that I'm not very familiar with, by the way, but I do have it in this presentation, such as in Vivo. And as far as I remember, back in the day, Rhodes did have some workshops on that too, and sometimes short courses as well on NVivo. So there are various ways of collecting data. There are different kinds of data, different research methods involved, hard numbers, quantitative often, but there's also qualitative methods as well that involve um, interpreting different kinds of things that are not necessarily numbers. And I see, yes, geology has lots of opinions based on qualitative stuff. And I find geology has to be quite an interesting one because sometimes geology can also be very much on the quantitative side too. When, for example, dating different things, dating different rocks. So, um, so geology is quite an interesting example. And then there are some disciplines that are just going to use both. I sometimes use both too. So, mixed methods are quite common. It's not uncommon to use both quantitative and qualitative research methods. Now, what do the different research methods look like? Well, you can collect data using interviews or focus groups. And what's that? Focus groups are basically just multiple interviews or multiple people involved in an interview. Surveys and questionnaires, which is very, very common, probably one of the most common data collection methods. Observations and experiments, often common in the hard sciences. And also in economics, A/B testing can often be used to test whether a product works well or not. And then there are people like me that often use secondary data analysis. So we often beg people, no, okay, that's a strong word. We often hope that when we collaborate with different partners or different disciplines, because by the way, data science and often computer science in general is quite cross-disciplinary, quite collaborative across the board. We look at all kinds of different disciplines and the data involved in it. So sometimes we look at sources where data is already collected, and we're going to look at different tools involved there too. I'm often involved here too, where I use different sensors. I use cameras quite often. I do surveillance. I automatically detect or count people, check whether people are doing what they're not supposed to be doing, etc. Even around my own house, by the way. But don't tell people that. Um, just kidding. So web scraping is another one. Personally, I'm not strongly involved with security and web scraping, although I was back in the day. Web scraping often brings up ethical questions that we'll look at later on, but you can't just grab content from the internet and be like, you know what, this is on the internet, so it's fine for me to use it as is. So you have to be careful about things like web scraping or just grabbing information from the internet. I see a question here from Tony Tendai. For qualitative research, do we use reliability, validity, and reproducibility, or are these mostly used in quantitative research? That's a very good question. They're often used in quantitative research, yes, but in qualitative research, there are different ways of measuring whether what we are looking at is accurate or not, right? Because that's basically the crux of the matter. The reliability and validity often revolves around whether what we're looking at is accurate or enough. Sorry, is accurate or not. Now, keep in mind, you're going to write this up as a thesis at some point or a paper for some of you that do studies via journals or degrees by journals. And in there, you need to back back things up with literature to show why things that are qualitative sometimes are valid as well. So with qualitative stuff, it's a bit harder to always validate things in a hard way, in a hard factual way. But you do have this body of knowledge which you should never ignore. Main reason why I started off with that in my presentation. You can't ignore the literature. In your discussion after you present your findings, you're often gonna your arguments and your discussion is gonna hinge upon what others did in the literature, and it's gonna compare often to what you found that maybe people said, maybe their opinions, stuff that you can't just be like, you know what, this opinion is 100% correct. You can't just do that, right? But reliability and validity and reproducibility will be important across the board, no matter what the research design is. So someone here says, Sibosiso says, I think the principles are transferable, but each is limited. Exactly. So you can't you can't say that this has to be 100% correct if it's a qualitative research design, because you often can't do that, right? But there are various tools like in vivo that can help you to determine whether it is, because these tools often help standardize things in the different disciplines and areas that allow you to, as a researcher, to be like, you know what, this researcher did that. When I've interviewed people on that exact same question, this is what I found. And they actually have some similarities, but they differ over here. That's the sort of stuff that can help us to strengthen the body of knowledge. And like Sibusiso is saying here, they're transferable, but they're limited. You can't always say this is 100% a fact based on what you're looking at. I don't really think we need to look at this. I think most of us know what an interview is. It's normally between two or more people, but it's often a systematic conversation. However, you do get unstructured interviews as well. So it's not something that I often do. So I don't know a lot about this, but you get unstructured interviews, you get structured interviews, but often you want to collect data in a very systematic way. You don't just want to do things in a roundabout way. Observations, often used in the harder sciences. And I say here that it can be observed through senses, almost like our senses, like smell, touch, hear, etc. But also ORS, right? Sensors, like measuring things using a stick, right? Using mechanical methods as well, using different gauges. Now, keep in mind that I'm not saying that quantitative studies are flawless, that when they measure things, they are not inaccurate. So both qualitative and quantitative have their different limitations, right? Just like Sibusiso said. Thanks for that, Sibusiso. Okay, so questionnaires. Like I said, questionnaires are one of the big ones that are used across the board of many disciplines. and it's often seen as one of the biggest ways or the most common ways of collecting data. In terms of sheer numbers, though, you could argue that the internet itself is the biggest source of where data comes from right now, because isn't that what different AI like ChatGPT, for example, are built on? They're built on scraping the internet, which is a bit of a questionable thing, but let's not talk about that. That's going to open a can of worms. Okay, so we've finally reached the part that we probably all came here for, right? Which is the application of data collection. So now that we know that we need to be grounded in the theory when we do all these things, we need to first look at what different tools are available, how we can collect data. Now, disclaimer, like I said earlier, I'm not an expert at all of these different tools. Some of these tools are fairly simple to use, so it's quite easy, but you're gonna find me playing quite a few videos here. They're gonna be only 2 to 3 minutes long, so don't stress out that it's gonna take a lot of time to watch these videos. So I'm gonna play these videos now, and I'm also gonna show you some tools myself. So once I'm done showing you the videos, I'm gonna show you some tools, and it's gonna become a little bit more hands-on for the tools that I actually use very often. Sadly, there's still more theory. Don't worry, it's not a lot of theory. So there are 6 W's, in my opinion, in data collection. That's the why. And I always start with the why, but now you should know Dane Brown is the why kind of person. So why is this particular data crucial for this type of research that I'm trying to solve, right? What is specific data and what needs to be collected? How? So what sort of methods and tools are appropriate? Something that we're going to look at now. Where? So different locations, study areas, etc. When? Right? So some have different time frames. Some things you can't collect at night. Some things you can only collect during the day, or vice versa. And then we get to the more ethical and managerial side of things. Who is responsible for collecting and managing this data, right? And also biases from what and from whom are the target, right? And also what's the groups and the systems that we're getting this from. So those are the sort of things we're also going to look at. So this is what I'm going to present to you now in the videos, surveys, and annotation tools. Online surveys like Google Forms and SurveyMonkeys, qualitative data like in Vivo and Atlas. I'm not going to be looking at that, but I just thought I'd mention it. I don't have experience with this, but I know many people use this, especially for qualitative data. Note that this doesn't mean that it's only limited to using it for qualitative data. It can be used across the board. What do I use? These are the things that I often use. So I use things that often can be applied to mixed methods. I often use Python, especially with different kinds of libraries like pandas, because I like to get technical and get under the hood of the engine and tweak things to my liking. We're going to look at image data management as well, because that's what I often do. How do we collect image data? How do we annotate it, etc.? And then we're going to look at other secondary data. You can also collect data that other people have already collected, or you can curate data, sorry, that other people have already collected. Something like Kaggle.com is your friend here. I'm going to take you through all of those things. I'm going to go to those websites. I'm not really going to spend much time here. This is just an exhaustive list. I'm going to provide the slides to you afterwards on all the different collection sources that you get. I can't promise that this is all of them, of course. From web scrapers to online surveys, marketing tools, customer advertisements, sentiment analysis, so social media monitoring. As social sciences, social media monitoring sounds, often our machine learning tools in data science gets used for this too. So we do automatic sentiment analysis using machine learning by training a model for that as well. Of course, knowing what the ground truth here becomes very tricky, and we often need an expert in humanities to help us over there. So you see, lots of this type of research is cross-disciplinary as well. Emails, tracking it, finding out what people said via emails, collecting data. questionnaire-based stuff, approaching people based on that. A and B testing, where you evaluate two different systems or products. And then there's all kinds of other things, right, over here as well that you can look at in your own time. All right, so let's check out Google Forms first. So I'm going to play a video now for Google Forms. I'm not sure what you can see on your screen over here. I don't know if you can see the chat and all these other things that I keep moving around in the presentation here, by the way. So please let me know if that's the case. But Google Forms is something that's fairly easy to use. So check out what this guy has to say.
And you'll see a blank form. Give it a title. I'm going to make a simple feedback form today. And then click to make your first question. I'm going to ask for people's name. And I have to choose the question type on the right here. So I'm going to choose short answer. Now let's make this required so people can't submit the form if they don't fill out this question. And click on the plus on the right-hand side to add another question. Now this time, when I wrote the question, Google Forms automatically changed the question type for me. And so all I need to do is put in some labels for this scale question, making it required again. And let's add one more, this time just for any other comments. And you see Google Forms automatically makes this a paragraph type question. Now to change how the form looks, I can edit the theme by clicking the palette icon at the top. You can change the fonts here. I'm going to leave them as they are and just click on choose an image instead. There are loads to choose from here, and I'm going to choose the jelly beans this time and insert that image. Once I've done that, I can then change both the accent color and the background colors. And if I want to see what this looks like now, I click on the icon that looks like an eye at the top of the screen. And this is what people will see when they go to fill out the form. So I'm going to fill it out quickly here now and click submit. And if I go back to my form, before I look at the responses, I realized that I would actually like to collect people's email addresses. So I'm going to click on settings at the top of the screen here, go to the responses section, toggle the switch for collecting email addresses. And I'm also going to toggle this other switch that limits people to one response. Now they do need to be signed into a Google account to use that though. All right, with that done, let's go and look at what the responses look like. You get this nice kind of analytics page here with charts and all of the individual responses. And what I recommend doing is clicking link to sheets here. And that's going to create a spreadsheet where all of the different responses from the form are gathered up. And every time someone submits the form, it's going to automatically add a new row to that spreadsheet. So once you're happy and everything's working okay, just go back to your form. The only thing left to do is to send it out to people that you want to complete it. So on the top right of the screen, click the send button, and you can either put in individual email addresses here and leave a message, or you can just grab a link. You can even shorten it to make it a bit easier, though it's still pretty crazy, and copy that link and then put it in your own email or a text message, for example, and that's it, creating a form in about 2.5 minutes.
All right. So as you could see there were two questions. One was on a Likert scale, which could be quantitative, and there was another one that could be interpreted as qualitative. Are there any comments? But unfortunately, the are you any comments question is a bit too open-ended to really use in a study. Could you just in the chat indicate to me whether you can actually hear the sound? Because I don't know if I switched on the sound in the sharing option. Could someone just please let me know if the sound actually worked? Okay, cool. Sound worked. All right. And that's basically the nice thing about your Google form is that it's fairly easy to use, right? So
To get started,
oh, I didn't want to do that again. So let me move to the next slide. And SurveyMonkey does something very similar to that as well. So yes, you'll get the links to the videos as well along with the slides, because you'll see that in this over here, if you click on check it out now, that actually links to the bottom over there to a YouTube video. So all of these are YouTube videos. And you know what I can do? Sorry, I can't. This thing doesn't allow me to go backwards now for some
to get
reason.
started,
So there we go. So for example, the first one was this link over here. That is the Google Forms one. So thanks for that.
to get started,
I'll actually do that from now on. So the next one is SurveyMonkey, which is this link that I'm sending now to everyone. But remember, all the slides will also be given to you, so don't stress too much about this. Now, the nice thing about SurveyMonkey is it has some AI analytics in as well. It can also allow you to do prompt engineering, so you can prompt it with what you want your survey to look like, and then it can create a survey automatically based on what you're prompting it. So remember, we're living in 2025 now, and it's probably a very good use case for AI, where you're not necessarily using it as a crutch, but you're using it for something quite useful. A/B testing, it can also do, but I'm not going to take you through that, but I will take you through that in the next video using something called Optimizely. So if we go to the next one, which is SurveyMonkey.
So to begin, click Build with AI. From here, you can either write your own prompt or edit one of our example prompts. These prompts cover a number of popular scenarios, from customer feedback to event feedback, and can also serve as a great starting point. If you're crafting your own prompt, be sure to give as much detail as possible. For example, if you need specific question types, like multiple choice, open-ended, or if you're looking for specific responses around customer experience metrics like customer satisfaction. Specify these details in your prompt for the best results. Things you'll want to include are your role, your survey goal, specifics about your audience, like education level, professional background, location, so that you can filter your results later. Include what you want to find out and how you'll want to analyze the data. Don't include sensitive information about your company or services. Let me show you how all of this comes together. I'd like to share a recent example of how I used generative AI for an event feedback survey after a webinar that I hosted. Here's the prompt that I used. I am a marketing manager at a medium-sized tech company based in the United States. I want to understand how we can improve our events by hearing from our attendees. I'm especially interested in measuring satisfaction on certain elements of the event, e.g., keynote speakers, length of sessions, etc. The goal is to identify areas where we can improve. Include customer demographics like location, gender, profession. The survey should also cover feedback on our event in their own words and how likely they are to recommend our event. I think this prompt looks good. To create, click the paper airplane icon, and just like that, it creates a whole survey for you. Usually takes a few seconds, but it can take up to a couple of minutes, depending on the survey complexity. Then, here it is. Your survey is created.
Okay, cool. So you saw that your prompt is very important over there, and knowing what to ask it is quite important. Interestingly enough, some people will chat with Gemini or ChatGPT, etc.
Alright, lekker aan voor jou. Dank je voor jullie ding.
Sorry? Oh, yeah. So some people that don't know how to prompt these specialized AI programs like SurveyMonkey, for example, they would ask ChatGPT or Gemini, etc., for help on how to do that, which is quite interesting. So that's like using AI to help come up with a new AI prompt, which is quite interesting, I thought. Okay, so the next one is Optimizely, and it's not going to show you an A/B test, but it's going to explain to you what an A/B test quickly is. I just thought that it's quite useful for those of you that are doing this kind of stuff. So Optimizely is basically your equivalent to Google Optimize. It can use machine learning to automatically identify trends and takeaways based on the surveys that you have worded, or layouts, or products, or anything like that. Okay, so it's quite flexible. So hopefully I include the correct link for this one. And I do. I think I do, yeah. Okay, so I've put the next link in the list.
Let's show you how
There you
A/B
go.
testing works. With Optimizely, in an A/B test, you take a web page or app screen and modify it to create a second version of the same page. This change can be as simple as a single headline, button, or a complete redesign of the page. Then half of your traffic is showing the original version of the page, known as the control, and the other half is showing the modified version of the page, the variation. As visitors are served either the control or the variation, their engagement with each experience is measured and collected in a dashboard and analysed with a statistical engine. You can then determine whether changing the experience had a positive, negative, or neutral effect on visitor behaviour. So why bother with A/B testing? Well, A/B testing allows individuals, teams, and companies to make careful changes to their user experience whilst collecting data on the results. This allows them to construct hypotheses and to learn why certain elements of their experience impact user behavior. And more than just answering a one-off question or settling a disagreement, A/B testing can be used to continually improve a given experience or improve a single goal like conversion rate over time. Finally, A/B testing one change at a time will help you pinpoint which changes had an effect on visitor behavior and which ones did not. Over time, you can combine the effect of multiple winning changes and experiments to demonstrate the measurable improvement of a new experience over the old one. To learn more about A/B testing and see some real-life examples, click the link in the description below.
All right. So you basically saw that they were talking about control and treatment groups earlier. So something that some of you might know as that. They call the control and variation groups. Something that you use hypothesis testing for, where you can control certain variables in an experiment. And that experiment could be especially applicable to questionnaires that you do. Okay. So I find that that's quite a useful tool that you could use if that's a sort of data collection methods that you want to do. There's also QGIS and other kinds of GIS software like ArcGIS. I'm not going to talk about it too much, but I just thought that some of you might be interested in this. Maybe the geologist. But yeah, so just a quick video on how to load a map with layers. That's basically what I'll show you.
As you can see, I've already browsed to the .gdb file. Before I did that, I clicked the directory button.
Oh.
And I've changed it here. It says open file GDB, and that's fine. So that's what we're looking for. And I want to click add layers, and close. And then we have 3 layers that are contained within that geodatabase. Now, if I go back to that and actually click on the zip download, I don't see it there, but if I go back to file and go back to the browse button and I try and add it via the original zip file, click open and add, you'll see add layers and close. It will still work that way too. The first way is the way I'd recommend them. So I go here, directory, browse to the unzip GDB, select folder, and you can add it that way. So you can see it's very easy to get it into your UGS project and work with this kind of data.
Yeah, so ArcGIS and QGIS are your most common ones. That was QGIS. I often used R instead. I just found that I had more control when I'd use it, but I'm not really an expert in that sort of stuff. The nice thing that you could do is, especially if you use Python or R, and maybe Arc or QGIS, someone could correct me in chat. You can pull things with different APIs. So you could pull stuff directly with Google Maps or whatever maps is your favorite to use, Garmin, etc. And you can collect data in a very, very automated way that by doing that. So I thought that that's quite useful too. All right. So now we're going to head to the for the last part of this workshop. I'm going to take you through things manually using my computer. And of course, it's going to involve my discipline. So in computer science, and especially in the data science field, we collect data from digital sources that we can find, right? So we're often mining data automatically from the internet, where we can either do web scraping, pulling it automatically, or we're getting it from different kinds of digital websites. However, there are people like me that also go out into the field to go collect data as well. For example, taking pictures of plant diseases using multispectral cameras, for example, or using UAVs, flying drones, etc. Not going to talk about that too much, but the point of this is that when you do this kind of thing, you can sometimes run into problems. And one of the main problems is that you can miss some values. Now, this applies to all kinds of things, to questionnaires, etc. as well. You could miss a house by accident. You could miss someone because they're not there. Sometimes you have to leave fields blank and you can't fill everything in. And the Excel spreadsheet or the CSV, which is a comma separated value file, which is equivalent to an Excel spreadsheet, which I often work with in Python and Pandas. Those things, they can often have missing values, and you have to use all kinds of different algorithms and mathematical methods like imputation to fill in those missing values. So keep in mind that data collection is not always a perfect process. And sometimes there are just limitations beyond your control. But we try to do our best and we try to collect enough data so that we do not have problems when this does occur. Sometimes we get tired, or maybe we're collecting data in a manual way and we duplicate data by accident, or maybe we automatically create the collecting data from some internet source. And sometimes it's the same thing that gets collected. And we have ways in computer science of automatically finding those duplicates and eradicating them. Then there's something that's common to many fields and many disciplines, and that's outliers. Sometimes, and that's why you have these controlled experiments and the control and treatment group. You let people in on a secret question. There are all kinds of ways to do it with surveys, etc. As well, not just with sensor equipment that measures things, where you can get outliers because someone might be a bad sheep that might be reporting on something in a way that's inaccurate. But basically, if you know that a distribution or the data that you're collecting has to conform to a certain distribution, and for some reason there are outliers that are not conforming to that, you could handle those outliers with all kinds of algorithms that can remove it. And the best part is that you don't have to understand all this computer science stuff. That's the best part. There are different tools that can automatically do that for you, such as Tableau and Microsoft Power BI. I don't use those tools because like I said, I like to control things. So I use Python and Pandas, and I program that myself. And then, of course, validating the type of data quality and the consistency you have, that there will be limitations across different kinds of projects. This won't be an exact science or an exact methodology in your discipline that you're using, but there are all kinds of ways to do that in data science that ensures that you have data that's valid and consistent. So sorry, I missed that part. Do you recommend to disregard? Okay. So it's a question that I often get when I lecture my data science course. What should you do with outliers? Should you always get rid of outliers? Should you keep outliers? Should you use methods that try to move outliers closer to the distribution so that your distribution looks normal? The answer is it depends. There isn't a direct answer that I can give you on this one. But basically, the thing that you might have missed is that I said, if you know that your data that you're collecting conforms to a very, very specific distribution, maybe the age in this population is always shown to be normal or close to normally distributed, but you suddenly see that someone, or not someone, but maybe you go to an area where you interview people and it's a rogue set of people. Suddenly you have 10 samples in a row where people are 110 years old. You probably know something is wrong there, right? Those are the sort of outliers that you're often going to remove. But then there are other outliers that are just very hard to know whether you should remove or not. So the obvious outliers are often removed using all kinds of statistical or mathematical ways or manual methods. The other obvious one is to create thresholds that automatically remove outliers in the case of ages and maybe the price of tickets for a concert or something like that, where you know that there was an upper bound for the platinum ticket. You know that ticket shouldn't cost more than 1,500 Rand for the platinum ticket. The entry level tickets maybe 250 Rand, for example. So you know that the ticket price is going to be between 250 and 1,500. So it really depends. That's the answer to that question. I hope that answers it. Why did it get dirty in the first place? This is quite a difficult question to answer as well. I mentioned it earlier that when you collect data, sometimes people collect data in a haphazard way from the get-go because the design is a problem. So maybe you don't have a structured way of collecting data in the first place, but sometimes you do. And sometimes you interview 100 people per day and you just get tired, right? So humans are fallible. We make errors. That could have gone wrong. That could have caused the dirty data. The other examples that I mentioned earlier was more for my discipline, where we automatically survey the internet and scrape things. We pull things from Google Scholar if it's academic based. We pull things like images from different websites automatically. I'm actually going to show you an example on that just now. And sometimes we get the same picture twice. But the best part is in data science, we have workflows that automatically take care of that for us if we do it properly. So we often want to set up our workflow properly in the first place. Now, here's another interesting one. Old data loses its value over time. But before that, I see I skipped one. You can suffer something called bit rot. Bit rot has lots of different connotations, but I think one of the most interesting bit rot connotation is actually part of this over time over here. So these two things go hand in hand over here, that old data loses its value over time. Because it could be outdated, that's one particular reason. But I don't know if some of you still remember stuff called CDs and DVDs. Before that, we had cassette tapes, etc., that could keep its data for longer. But we have the problem where we can actually lose data if we store it for 15 years. And that's an example of it. Data can become corrupted. Flash drives actually are one of the best examples of that. If you store something on a flash drive for 2 years, depending on the quality of that flash drive's flash memory, you could lose that information as quickly as 2 months. So be careful with storing data for long term on a flash drive, for example. And then here it says any combination of the above as well. Okay, so we still have some time left. Let's look at our first actual case where we look at a tool directly on my computer, something that I use extensively. I've been looking at penguins since the end of last year. Before that, I've been doing a lot of work on fish counting, fish detection, fish segmentation, so that I can eventually monitor habitats, etc. But I've been approached by both SciAp and SandPark, so I've been working a lot on these kind of things. The penguin, especially the African penguins, are a big deal because of it being critically endangered, not just endangered. So it's something that is actually becoming a national imperative now for us to look at penguins. So there's something called the RoboFlow. Now, this data set is already part of my project, and it's called app.roboflow.com. You see over here. And you can upload your images. So for example, if this is a plant disease project, I could take a lot of pictures of a farm that contains lots of wheat to check if I can automatically detect the wheat mosaic virus, something that I've actually done before. But in this case, it's penguin data. And the problem with this kind of thing is sometimes you have to curate and annotate the data. Now you'll see that the yellow or green boxes drawn around these penguins to segment them, that's known as ground truth. But there are several of these images, which I'm clicking on now. The first one, and hopefully you can see this quite well, that there isn't ground truth for these. And we need to know the ground truth when we're training a machine or doing machine learning, because otherwise we won't know whether our predictions are correct or not, right? So this is very much on the quantitative side of things. Now, I just need to move the chat here before I move on. So now I can use something called a polygon tool, and I can draw. For some reason, my computer is struggling over here. I don't know why, but yeah. I can draw around the penguin the more accurately I draw this, the better. But you can see it can be quite a tedious process, especially if I need to do this for 1,000 images or more. Sometimes we need 1,000,000 images, and and 1,000,000 images can contain multiple penguins. So that's the first thing that I wanted to show you. We could do it using a polygon tool or some sort of bounding box tool where we just draw a box around it instead, which is less accurate than segmentation. Or we could use AI labeling that RoboFlow offers us that actually enables us to automatically annotate things. Now, for some reason, my computer is struggling right now. I'm not really sure why. So it's really slow, but I just clicked on this and automatically it drew the box around it for me. And that's obviously great, right? And I can just click finish and there it stores it as a penguin for me. I can also delete this one, or I can convert this one to a smart polygon, which is also quite nice. Now, what about, so I've collected all this different data on penguins and I'm annotating it. So this is a nice tool for that sort of purpose, right? What about secondary collection methods? Because remember, I told you that I'm going to talk about secondary collection methods too. Now, that's another thing RoboFlow does quite well. And that one's called universe.roboflow.com. So robo.universe.com can enable you to find all kinds of image-based data. So if I want to find stuff on birds, I can search for it like this. I can click on advanced filters. I often want to have enough images. So I want a minimum of 1,000 images per class. And a class in this case is a bird. It could be any kind of bird, right? A pigeon, it can be anything really that I'm looking for. Or it could just be bird as the class itself. So here I found a data set that has 2,185 images because I'm asking for at least 1,000 images, right? Before this, it was giving me any amount of images. I can also say that I want it to be instant segmentation because earlier I showed you with the penguins that I segmented things. So here's a data set that has 1,007 images of parrots. So that's quite interesting. So the nice thing is I don't have to annotate this at all. Something that I skipped and I kind of forgot about, sorry about that, is that I can also automatically do this with or without RoboFlow. I often do it without RoboFlow because it's quicker, because RoboFlow is online. But I can click on something called Label Assist. And I've already trained a machine learning model to know what a penguin is. And this thing is supposed to bring up my penguin model now, but it's being very slow. Not really sure why. I've also trained it on other animals, not just penguins, but I really wanted to show you. Okay, here we go. And this model that I trained had about 92.5% absolute precision, which is basically a kind of a metric that we can use as accuracy. So now with Label Assist on, in theory, it's automatically supposed to annotate things for me. So if I go to my next image, in theory, it's supposed to draw boxes around it automatically, and it has. It's drawn a box around this image, and that one. Not perfectly, but it's drawn it. However, it seems to have missed these two at the back. So my model is not perfect, but I can still manually annotate the rest. Okay, so that concludes the RoboFlow one. Don't know if there are any questions, but I don't really have time to really linger a bit too much on that. The next one is web scraping. So there's something called Beautiful Soup. And I'll open up my terminal for that now. But before I continue, I'm just very curious to know why my computer is struggling. So for some reason, my computer is struggling over here. Okay, so it's some graphical thing that's taking up all my CPU. I'll investigate that further once I'm done with this workshop. So I created a Python script called simplecrawler.py. Now it's quite technical and quite a lot of code here, so I'm not going to go through that. But I can go to something like maybe a news bulletin. So I just looked at today's news thingy on CNN. Yeah, too many tabs can also cause that, but I think it's something to do with RoboFlow actually that's causing it. I'll actually close RoboFlow just now. So I can click on, I can call this script and I can call a URL and try and extract images automatically from it. When I click enter, it says created a directory called crawled images, and then it's downloaded images from that. Let me close that two RoboFlow things. And it's this news article over here that it's going to scrape these images from now automatically for me. Now, of course, it doesn't have to be a news based web page. It can be anything really that you do it on. And now I'll go to my folders where it created it now. And as you can see on my computer, I automatically downloaded that images now, which is actually quite nice. It's a nice thing to quickly download data and collect data that's image based or other things based. You don't have to necessarily web scrape images. You can web scrape any kind of data. You can web scrape Twitter websites. You can use sentiment analysis using machine learning, etc. Curious to know whether it fixed it, and it hasn't. So maybe it's Zoom that's doing it. The last thing that I want to show you before I end this workshop is Kaggle. And I feel like this is like the gold mine because it's not just for computer science, although you see the word computer science, computer vision, etc., and many computer science terms there. There are several kinds of data sets that you can get from here. What is Kaggle? Kaggle is actually for competitions, for programming, but it's become a lot more than that over time. It's become it's become a place where you can store data sets such as stress analysis in social media. This is an example of a qualitative study where you'd run sentiment analysis on this using machine learning, in my case. In your case, if you're interested in this kind of things, I'm not sure what you would do with it. If it's a customer-based thing, you could do all kinds of different economics-based testing on it. You have your methods that I'm not familiar with. You could also look at other kinds of data sets over here. You can say what kind of data sets you want. If it's data sets on education, you can click on education, students' habits versus academic performance, and several different other kinds of data. So I find Kaggle to be the gold mine. It's quite an easy thing to remember. It's just kaggle.com. You can actually go to the datasets tab if you want to do data collection there, of course, as a secondary data collection method. Okay, so that was Kaggle. And then just lastly, we need to also keep in mind that we all have all those different kinds of tools. The tools are interesting to use. They're very useful, but when you do questionnaires, you have to get consent first, right? In fact, before that, it has to get ethical approval by Rhodes or by the university that you're from. You have to promise a few things, such as anonymity, etc., depending on the way you applied for ethics. Most of the time, this applies. Maximum benefits, minimize harm. Those are just very good principles to follow in general. Other stuff called integrity, bias awareness. You don't want to fabricate things, right? So when you collect data, you don't want to create the narrative because you just want your research to go a certain direction. I have to mention these things. I know it's not nice to talk about it, but these sort of topics are things that do happen in the real world. So please do not plagiarize, do not fabricate data so that it has a specific narrative. Avoid potential biases. The other one is that we have all these different kinds of data that we can collect now, right? Especially if it's digital. Where do we store it? Where do we manage it? ITS can help with that sort of stuff. We have the Strubin building. They have certain places that can help with that, although it's not exhaustive. So when I wanted to collect data on biometrics, they actually didn't have a facility that could help me with that sort of thing because there are certain conditions and policies that it has to fulfill in order to be allowed to be stored on specific sites. So if they want it to be stored at Rhodes University, there's certain things that the computers and servers have to conform to be classified as secure and to be classified as something that they are happy with. So sometimes they just have very, very weird things that there's a thumb suck, depending on the company that you are working with. So just keep in mind that these dedicated centers and things that you store stuff on have to conform to certain policies if it's digital data. And yeah, that's basically the end of the presentation. This is just basically, again, talking about the different outliers and inconsistent data, but this is just supplementary and you can read on this in your own time. This is my final slide. My final advice that I have for you is you need to read, right? You need to be informed. I talked about that right up front. So reading the literature is important so that you avoid sampling errors. You need to know what sort of samples are representative of the problem. So read the literature. Measurement errors, sometimes it's not the human being that gets tired. Sometimes you buy a bad sensor. Please, you don't always want to only use one sensor. So for example, if you want to measure temperature, sometimes you have to have 3 temperature sensors. So you have to measure things thrice. Sometimes in computer science, we do things 10 times. Tenfold validation, we often call that. And then there's all kinds of other things like confounding variables that you have to account for. And there are all kinds of softwares that can help us with that, especially R and Python with pandas. Researcher bias, something I talked about. You don't want to fabricate data. You also want to ask questions in an objective way. You want to be transparent with your group when it's a questionnaire. Insufficient documentation. If someone has to be part of the project and someone has to read things, you don't want to have the wrong documentation. But another big thing is once you're done with your project, the next researcher needs to be able to reproduce what you do. So please keep that in mind too. Adding to the body of knowledge is one thing, but having it reproducible so that the next person can build on it is also important. Ignoring negative results, this almost forms part of this ethics and fabrication of data and results problem. You don't want to do this kind of thing because even a negative result can contribute to knowledge. And with that, I end my presentation. And if there are any questions, I'm open to it right now. You have all these different tools that you can plan with, etc., etc. Please use them. These tools are not perfect, but they can help accelerate your research dramatically. Thank you. So, any hands up? Any questions? Seems like I've actually ended at a good time. 3 minutes to spare. Please share the recording. Yeah, I'm going to leave that to Postgrad Center to do. So the Center for Postgrad Studies will do that, I'm sure. I don't mind sharing my secrets. So what I'll tell CPGS to do is to share both the recording and the slides with you. Thank you very much. Yeah, I try my best. Thank you. Yeah. Okay, so I don't see any hands up. I do see something about, okay, I see something now. Briefly explain crowdsourcing. Okay, so crowdsourcing is not something that I'm very familiar with. It really depends on how you're doing it. Remember, I mentioned something called questionnaires earlier where, let me just go back here, sorry. We had focus groups where you could have multiple people involved. That could be a form of crowdsourcing, perhaps, where you have multiple people involved, but crowdsourcing could mean something totally different that you're referring to, Amelia. So sorry, I don't really have a perfect answer for exactly what crowdsourcing is. It could mean a lot of different things based on the discipline and the field of study. All right. Okay. So I'm going to stop sharing now. And I want to thank everyone. I want to thank CPGS as well for asking me to do this, giving me the opportunity. I want to thank everyone for attending. I saw there was quite big numbers earlier on. And please enjoy the rest of your week. If you're studying for exams or whether you're doing research, all the best with that.